Now let's take this problem. In the following figure, ABC, ACD, ADE are right angle triangles. If AB by BC is equal to CD by AC is equal to AD by DE is equal to K, then find the value of AE by BC whole square. Now friends, to make the problem simple, since this is a right angle triangle, I assume I take a Pythagorean triplet, that is 3, 4, 5, right? I assume this to be 3, this to be 4, so automatically this will be 5, right? Now again, AB by BC is equal to CD by AC, right? So the same if I apply over here, so it will be 20 by 3, right? Now 20 by 3 whole square plus 5 square, that will give us a 400 by 9 into 25, that is 625 by 9, so it is 25 by 3, right? So this is 25 by 3. Now AB by BC is equal to AD by DE, so AB by BC is equal to AD by DE. So if 4 is 25 by 3, 3 must be 25 by 4, right? Now again, this is perpendicular, this is base, so 25 square by 9 plus 25 square by 16, so it must be 25 into 5 by 3 into 4, length of AE, right? Now we have to find out AE square by BC square. So AE is this, that is 25 into 5 by 3 into 4, and BC is 3, and we have we have the square, right? So 125 by 36 square, okay, or I can say 5 raised to 3, that is 6 upon 3 raised to 2 2s are 4 into 2 raised to 4, so 3 into, or we can say 6 raised to 4. Now we know the value of K is 4 by 3, and this we have to get from the options, right? While putting K is equal to 4 by 3, we must be getting this, right? Here if I put K is equal to 4 by 3, I'll be getting I'll not be able to get this because this is going to be 6th power, so this is ruled out. K cube, that is 4 cube by 3 cube, so 4 cube is 64, so 64 plus 27, it will give an absurd value. We want something like 5. Now 1 plus K square and then whole cube, so K is equal to 4 by 3, so 4 square by 3 square, so 4 square by 3 square, that is 16 plus 9, 25, and yes, it may give the correct answer, so I just do it carefully. So 1 plus 16 by 9, that is 25 by 9, and K square is 16 by 9, right? And this is cube. So this is we don't have to check the denominators, 5 square and cube, so 5 raised to 6 we are able to get it over here, so no need to check further and no need to in fact solve further. Just mark this will be the correct choice because this is 1 plus 1 upon K square, so K square is this 16 by 9, so this will not give this value, right? So this is how you can solve this problem. No doubt it is taking some it will take some 1.5 minutes, but the problem is really simple. Maybe other methods are also there to solve this problem. Okay, so I got this method instantly, so I just using this one. I hope you are clear. Now this problem, arc P1 P2 is a quadrant of a circle with center O. A square Q1 Q2 Q3 O, Q1 Q2 Q3 O, this is the square that is drawn, and similarly a quadrant, this is drawn, and this process is continued infinitely. Find the sum of areas of all the squares so formed if the radius of the circle having quadrant P1 P2 O is R. Okay, so this complete length is R, that is radius of this circle, that is this is R, right? So now just see it carefully. This is radius of the circle and this is actually diagonal of the square, that is outer square. So suppose the side of the square is x and this is also x, from here to here, that is x, right? So x square plus x square is equal to r square, that is a radius of this outer circle, right? So 2x square is equal to r square, that means x square is equal to r square by 2. That means area of this square is r square by 2, right? Now generally what happens when the figures are inscribed inside one inside other, then this area of the next square will be half of this and so on, right? I just can prove it before you, but generally it happens, so you be careful. If you are not able to get enough time in your exam, you can use this funda. Now see x square, that is the area of the outer square, that is r square by 2, right? Now this length from this point to this point, the length is x, that is nothing but the side of the square. Now for this square, it is side of the square. For this circle, this quadrant circle, it is radius of this circle, right? So this will also be x from this point to this point, right? So this is x. Now I assume the length of or the side of the square to be y, right? So this is y, and from this point to this point it is again y. So y square plus y square is equal to x square. So 2y square is equal to x square by 2, right? So I'm sorry, 2y square is equal to x square by 2, right? Or I can say r square by 4, right? So you see, area of this outer square is r square by 2, area of this inner square is r square by 4, and the same thing will happen further, right? So you don't have to calculate it anymore. Now sum of areas you have to find out. Since this is an infinite geometric progression, you can use the formula a upon 1 minus common ratio. So a is the first term, that is r square by 2, and common ratio is 1 by 2, so 1 minus 1 by 2, that is 2. So sum of areas will be 2r square, right? So that's pretty simple. I hope you are clear. Now ABC and PQR are triangles such that PQ is parallel to BC, QR is parallel to AB, and PR is parallel to AC. Okay, BC, AB, AC, and PQ, QR, PR. In PQR, 2PD is equal to DQ, and in triangle ABC, BI is equal to AD is equal to 2DI. Find the ratio of areas of triangle ABC and PQR. Now first of all, ABC and PQR, these are two similar triangles, right? Because PQ, QR, PR, they are parallel to BC, AB, and AC respectively, right? So both the triangles are similar to each other. Now similar triangles, their areas are in the ratio of squares of their side, right? So we just have to find out the dimension of, or we can say we have to get this idea of sides. Now in PQR, 2PD is equal to DQ. 2PD, I assume PD to be x. So if this is x and 2PD is equal to DQ. Now figures are symmetric, right? So this length, if this length is x, and this length must be 2x. So the total length of PQ must be 3x, right? Similarly, in triangle ABC, BI is equal to AD is equal to 2DI. So BI I assume to be DI I assume to be y, then it must be 2y, and this must be 2y, right? So the total length must be 5y, right? Now do not get into the values of x and y, whatever they may be, but we have to consider these figures 3 and 5, right? 3 is a figure that is coming out of triangle PQR, and 5 is a figure that is coming out of triangle ABC, right? So as I've already told you, areas are in the square of ratio of squares of sides, right? So ABC must be, area of ABC must be 9 part, and area of PQR must be 25 part, right? So ABC by PQR, ABC is 25 and PQR is 9. So don't get into for the values of x and y, whatever they may be, your answer is 25 by 9. Okay. Now this problem, there are two concentric circles such that area of outer circle is 4 times the area of inner circle. Let ABC be 3 distinct points on the perimeter of outer circle such that AB and AC are tangents to the inner circle. If the area of the outer circle is 12 square centimeters, then the area of the triangle ABC would be. The first thing is area of outer circle is 4 times the area of inner circle. That means radius is double. So I assume that the radius of this inner circle is R, then the radius of outer circle must be 2R. So this figure is not given in the question. I have drawn it for you. You have to draw this figure on your own in your exam, right? Now AB and AC are tangents to this inner circle. I'm not bothered about BC. Maybe or may not be it is a tangent, but I'm not bothered about it. Now this is R, this is 2R. So this length must be, according to Pythagoras theorem, must be root 3R. And this angle must be 30 degree, right? Perpendicular by hypotenuse, that is 1 by 2, that is sine 30 degree, right? So this angle is 30 degree. This angle is 90 degree. So 90. And similarly this is R and this will be a root 3 by R. So this angle will also be 30 degree. So if this is 30, this is 90, then this must be 60. Right? So this is 30, this must be 30. So this is 60, this is this should also be 60 by the same logic. So because AB, this is 60, this is 60, then the third length should also be 60. Third angle should also be 60. That means ABC is nothing but an equilateral triangle. Now what is the area of an equilateral triangle? That is root 3 by 4 side square. Now side is over here 2 root 3 R. Right? So this is what the area of this triangle, right? Now R is actually pi into outer circle is 2R. So area of outer circle, or I can say area of inner circle, is pi R square is equal to 3. Right? Area of inner circle is 1/4 of this. So area of inner circle is pi R square, radius is R, so pi R square is equal to 3. So you can put the value of R square from here, root 3 by 4 into side square. I'm sorry, I forgot to do this. So it is root 3 by 4 into 3 into R square, and R square is 3 by pi. Right? So it is 9 root 3 by pi. Okay, this is your answer. So it doesn't involve too much calculation, but yes, you should be clear with the logics, with the concepts. I hope you are getting it. In the following figure, AB is equal to BC, AC is equal to CD, and ACD is 90 degree. If the radius of the circle is R units, and find the length of the chord BC, right? The first important thing over here, AD is diameter, because this is 90 degree, that means angle in semicircle is 90 degree, right? So I just draw a line over here. I just draw the diameter over here. That's this, right? So this length is 2R. Now I assume this to be x and this to be x, right? So x square plus x square, that is 2x square is equal to 4R square, because this is diameter and radius is R, that means this is 2R. So 2x square is equal to 4R square. So I can say x square is equal to 2R square, or I can say x is equal to root 2R. Okay, that means this length is root 2R. This length is root 2R. Next important thing is, say if we drop the perpendicular from center to a chord, it bisects chord. That means this angle is 90 degree and this length is equal to this length, right? This is 90 degree, this will also be 90 degree, right? Now what, this length is root 2R, and this triangle, this is the midpoint of this line, this is the midpoint of this line is parallel to this line. That means according to midpoint theorem, this length must be half of this length, right? This length must be half of this length. So this length must be root 2R by 2, or I can say R by root 2. From this point to this point, it is R by root 2. From this point to this point, suppose it is O. This complete length is radius of the circle, that is R. And this length is R by root 2. So this length must be R minus R by root 2. Okay. So we got this length. we have this length, the complete length is root 2r, this complete length is root 2r, so this length from this point to this point it will be r by root 2. So this length is r by root 2. Now we have this length, we have this length. So using Pythagoras theorem we can find out this length, right? So for that square of this plus r square by 2. This is your answer, right? So it is r square plus r square by 2 minus 2r square by root 2 plus r square by 2. So r square by 2 plus r square by 2 is r square plus r square 2r square. 2r square I can take common, then it is 1 minus 1 upon root 2, right? So you can just solve it and you can find out the correct answer. As far as I can see, this will be the correct answer, right? After that you need to take the square root because this is ab square, right? So after that if you solve, you'll be getting this as your answer. Okay. Now this question. Two straight roads R1 and R2 diverge from a point A at an angle of 120 degree. Ram starts walking from point A along R1 at a uniform speed of 3 km per hour. Shyam starts walking at the same time from A along R2 at a uniform speed of 2 km per hour. They continue walking for 4 hours along their respective roads and reach point B and C on R1 and R2 respectively. There is a straight line path connecting B and C. Then Ram returns to point A after walking along the line segments BC and CA. Shyam also returns to A after walking along segments CB and BA. Their speeds remain unchanged. The time interval between Ram's and Shyam's return to point A. Right? Now this is the situation. This angle is given to us as 120 degree. Right? Now Ram is starting from point A towards R1, right, at the speed of 3 km per hour. So after 4 hours he will reach B, so he might have covered 12 kilometers. So this is 12, right? Similarly, Shyam is starting from here in this direction and his speed is 2 km per hour. So after 4 hours he'll be walking for 8 kilometers, right? Now we can calculate the distance BC, the length BC, using cosine rule, right? We know this angle. Now cos 120 degrees, cos 90 plus 30, that is sine 30, that is negative, it will be negative. So cosine formula is cos 120 degree, that is minus half. I am not writing it over here, you must be knowing this. 12 square plus 8 square, that is 144 plus 64 minus BC square upon 2 into 12 into 8, right? So BC square is equal to 96 plus 64 plus 144. So that's come to precisely BC, this is 16 into 16 ones are, and then we have 14, 144, that is 9. So that is actually 16 into 19, BC square. So BC will be 4 root 19. Okay. Now we got this length. Ram returns to the point A after walking along line segment BC and CA. That means Ram is now covering 4 root 19 plus 8, right? So he will take, his speed is 3 km per hour. So this distance 4 root 19 plus 8, he will take 3 km per hour, this much time. And the other person who is at this place, he'll be taking 4 root 19 plus 12 by 2, right? So this is the difference between their timings. Now you can simply solve it. It is 2 4s are 8 root 19 minus 12 root 19. This is bigger than this precisely. So 12 root 19 minus 8 root 19, that is 4 root 19. And it's an even figure, so 2 will be taken as common. So we need actually 2 root 19, right? After that it is 16 and 36. So 20 divided by 2, 10. Okay, this one is the correct choice. Okay, And the problem is it involves bit calculation, but not at all difficult, can be easily done in 1.5 minutes. You must be knowing the cosine rule, otherwise you won't be able to do this problem, right? You will not be able to find out the length BC. Okay, I hope you are clear. Now see this question. Two coins are put in a square of side 1 as shown in the diagram. The sum of the radii of coins is. Okay, so this is square with the side 1. I just draw this line. Now I assume the radius of this bigger circle to be capital R and this to be small r. Now what? This is the center of this circle. This, right? This is, and over here also the same thing. Now this length is R, right? This length is also R, this length is R, this length will also be R. So this must be from this point to this point. This is diagonal of this square, so this must be R root 2, right? Similarly, it is R, that means it is R root 2 from this point to this point. Now from this point to this point it is R, and from this point to this point it is capital R, right? So we know the 4 length, 1, 2, 3 and 4. This 4 altogether is nothing but the length of the diagonal, right? And length of the diagonal is what? 1, 1. So it must be root 2, right? So precisely R root 2 plus R root 2, I just can take root 2 as common. R plus R plus R plus R. So R plus R, and this is root 2 plus 1, right? So this complete length is actually equal to root 2, that is nothing but the length of the diagonal of this square, right? So R plus R, that is sum of the radii, will be root 2 upon root 2 plus 1. You just do it rationalization, so it is root 2 into root 2 minus 1, or you can say 2 minus root 2. Okay, pretty simple. Now find the area of a triangle whose vertices are this, this and this. Okay, so I just draw them over here. It's 0, 0. Then we have 12, 9. I assume 12 over here and maybe 9 over here. So this point is this. Okay, so this is what? 12, 9 and 14, 6. So 14 somewhere here and 6 somewhere here. So this is this point, right? Now I just complete the triangle. So this is a triangle. We have to find out the area. Right now, to make the problem simple, what I can do is I can make a rectangle over here. So the length of the rectangle must be 14. Okay, and height must be 9. Right. Now this point is 0, 0, this point is 12, 9 and this point is 14, 6. Okay. Now simply we can find out the area of this triangle. See, we know the area of this rectangle, that is 14 into 9, that is 126. From this we can find out the area or deduct the area of this triangle, right? So this length is 9 and this length is 12, right? This is 9, this is 12. So 12 into 9, 108 by 2, 54. Then we can deduct the area of this triangle. So this is 14 and this is 6. So 14 into 6 by 2, that is 14 into 3, that is 42. Similarly, we can deduct area of this triangle. So from here to here the length is 12 to that's 2, and 6 to 9 this is 3, right? So 2 into 3 by 2, so that is 3, right? Easily we can find out the area of this triangle. So from this entire rectangle we deducted this, this and this, so remaining is the area of triangle. So 4 and 2 6 and 3 9, 5 and 4 9, 126 minus 99, that is 27, will be the area of this triangle, right? Pretty simple. I hope you are clear. Now, an arbulos is the region bordered by 3 mutually tangent circles with collinear centers. See shaded region in the figure. If the area of this region is 42 pi and the radii of 2 smaller circles have a ratio 2:3, what is the radius x of the upper and the largest circle? Okay, fine. So this is the center of this large circle, right? This length is x, so this length must also be x, right? Now I assume the radius of this as 2y and radius of this semicircle is 3y, right? So this total length is 4y, this total length is 6y, right? So from here to here the total length is 10y, and this is actually 2x. So 10y is 2x, that means x is equal to 5y. That is the first relation that we got, right? Now area of the shaded region will be obtained by area of this region minus this, right? So basically area of semicircle is half pi r square, so half and pi can be taken as common. Now r square, that is x square, and x square I can write down 25y square, minus area of this semicircle, that is 4y square, 2y is the radius, so 4y square, minus 9y square, and that is actually 42 pi. Pi and pi is cancelled. It is 25 minus 13, so 12y square by 2, so it is actually 6y square. So y square is equal to 7, so y is equal to root 7. Now we have to find out the value of x. So x is equal to 5y, so 5 root 7. Okay, pretty simple. Now this question, a piece of paper is in the shape of a right angle triangle, and it is cut along a line that is parallel to the hypotenuse, okay, leaving a smaller triangle. There was a 35% reduction in the length of the hypotenuse of the triangle. Okay, if the area of the original triangle was 34 square inches before the cut, what is the area of the smaller triangle? That's pretty simple, interesting problem. I draw the initial structure first, that is this one, right? After a cut may be something like this. Okay, now what? See this triangle OPQAB. Triangle OAB is similar to triangle OQP because this line is parallel to this line, right? So this angle will be equal to this angle will be equal to this angle, and this is common. So triangle OQP is similar to triangle OAB, right? Now if the two triangles are similar, their areas are in the ratio of squares of their side, right? So there was a 35% reduction in the length of hypotenuse. Suppose this is the length x, then this will be 35% reduction, so it is 0.65x, right? So area of triangle AOB, or we can say this area by this, right? So that will be x square upon 0.65, or I just can say 65 square is 4225, 0.4225 x square. So area of bigger triangle by area of smaller triangle, right? And area of the original triangle is given to us as 34, right? So that area of this triangle that we have to find out. Here I am writing down the ratio of areas, right? So suppose this is y, that is the area of the smaller triangle, right? So y is equal to 34 into 0.4225, right? So 0.42, that is something around 50% of 34, a bit less than 50%. So 34, 50%. Okay, there's we have three options, so we need to be careful about it. In fact, all of the options are bit less than 17, so we need to be careful in calculation. Or instead what you can do is you can go by digital root method, right? You just eliminate the decimal. It is 7 into 4 5 9 and this 4 7 into 4 28, that means 1. The digital root 1 we want, right? So here it is 6, here it is 6 6 6, here it is 5 4 plus 5 9, 6 and 1 7 and 5 12, it's 3 over here. 6 and 3 9, 5 and 4 9, it's 1 over here, right? So that's easy. Just go for the cross verification. 6 and 5 11 and 1 12, so it's 3 over here. We want 12, so this is the correct answer. Okay, again this is the ratio of areas of these two triangles, and this is also the ratio of areas of two triangle. Here the exact value of area of the outer triangle or the bigger triangle is given, and we have to find out the area of the smaller triangle, right? So this calculation, this much work we have to do, right? Not very lengthy, not at all difficult. This question, AB is a diameter of semicircle ACB where C is the midpoint of arc ACB. Find the ratio of perimeter of the semicircle and triangle ABC. Okay, pretty simple, interesting question. Here I just drop this line. This is from C only. Okay, now see this length arc AC is equal to arc CB. That means this angle must be equal to this angle, and this complete angle is 180 degree. That means this is 90 degree, right? Now if it is 90 degree and these two lengths are same, both of them are radius, so this must be 45 45. Okay, now this is suppose I assume the radius of the semicircle is r, so this is r, this is r, that means it is r root 2. This is r root 2, this is r root 2. So perimeter of this triangle will be r root 2 plus r root 2 plus 2r, right? 2r plus 2r root 2, right? Or I can say 2r 1 plus root 2. That is the perimeter of triangle. And what is the perimeter of this semicircle? Perimeter of semicircle is pi r plus 2r, right? So it is r I can take as common, and here inside the bracket it is pi plus 2, and this is 2r 1 plus root 2. So this is pi plus 2 is to 2 1 plus root 2, and even you can rationalize it. It is root 2 plus 1, so multiply by root 2 minus 1. Multiply and divide. So in numerator we have root 2 minus 1, and in the denominator we'll have 2. So this one is the correct answer. Okay, pretty simple. In the figure, chord AB is equal to chord CD, angle AOB is this, BOC is this, find the measure of angle BOD. That's pretty simple problem. See, you must be knowing one property, that equal chords subtend equal angle at the center, right? So if AOB is 60 degree, that means this angle is 60 degree, then that means this angle, that is angle COD, will also be 60 degree, because AB is equal to CD. They are equal chords, so they will subtend equal angle at center. Now this complete angle is 60 degree and BOC is given to us as 15 degree, so obviously this must be 45 degree, a matter of 30 seconds. Now the difference between the interior and exterior angle respectively of a regular polygon is 120. Find the number of sides of polygon. So this is pretty simple. See, this is the structure, right? This I suppose x, then it must be x plus 120. Precisely this is x plus 120 and this is x, right? And sum of these two is 180. Okay, so 2x plus 120 is 180. That means 2x is 60. That means x is equal to 30. So this angle is 30 and this angle is 150, right? Now sum of angles of a polygon, that is n minus 2 into 180, right? N sided polygon, this is sum of angles. Divide by n, that is value of one angle, and that is 150 over here. So we have to find out number of side, that is a value of n. 36 and 35, so it's 12, right? Pretty simple. 6n minus 5n, n is equal to 12. Now this problem, in a trapezium the two parallel sides have length a and b, where a is less than b. Each of the other sides of trapezium has length c. Then area of the trapezium is, I just draw one trapezium over here. Okay, this is the trapezium, and since it is an isosceles trapezium, I just mark. So this length is b, this length is a, and this length is c, and we have to find out the area of this trapezium, right? Now to make the problem simple, I just take the comfortable values of a, b and c, right? First thing, and the second thing is, see what I do is, I just make this mark. I cut this triangle from here, and I just add it over here, right? Now this is precisely a rectangle, but the area of this rectangle and the trapezium will be same, because I have cut this triangle from here and I have added this over here, right? Now the problem becomes simple. Now here, see this c, that is actually this length, it is actually a slant length, right? I am interested in this length, and this length. So what precisely I am interested in this length. So what I can do is, I am getting a right angle triangle over here. So what I do is, I assume this length to be 5, right? This to be 5, this to be 3, right? I am assuming this length to be 5, this to be 3, and suppose this to be 4, right? So if this is 4, this will be 4, and if this is 3, then this will also be 3. So by calculation, this 5, this is 3, and this will be 4 once again. Right? See, I am assuming 1 length, 2 length, and 3 length, right? This is coming out of this calculation, right? Do not get confused. You cannot assume all the values. At least one value should come out of calculation, right? Now area of this rectangle will be what? 4 plus 3, 7 into 4, 28 square units. Okay, now you have got the values of a, b, c. C is 5, b is actually the total length, that is 4 plus 3, 7 and 3, 10, and a is this length only, so that is 4, right? Now put up the value of a, b, c among the option and just get answer as 28. So whenever you are getting 28, that will be the correct option. So a plus b into c, a plus b, that is 14 by 2, that is 7 into 5, we are getting 35 in this case, so it's wrong. Here it is half a plus b, so it's half, a plus b is 14, so half of 14 is 7, into c square, that is 25, minus b minus a whole square, 10 minus 4, 6 square, that is 36, 36 by 4, 9, so 25 minus 9, 16, right? So if it comes out of the square root, it will be 4, so 7 into 4, 28, so we are getting 28, so this one is the correct choice. Once again, the important point over here, see, this was a original trapezium, it's an isosceles trapezium, and I assumed the length of this parallel sides and this, right? You can draw a trapezium having the sides as 4, 10 and 5. You can draw that exists very well, right? So I have drawn the trapezium according to that, and after that I cut this triangle, this portion from here, and added it over here, right? Just join this over here, right? So I'm getting a rectangle which having area, having side, this side as 7, and this side we can calculate using Pythagoras theorem. So this is 5, this is 3, this is 5, that this must be 4. So area of this rectangle is 28. We got the values of a, b, c, put it over there, you'll be getting 28. So this one is the correct choice. No need to calculate further, because here it is b minus a whole square by 4, here it is only b minus a. So nothing else will produce the same value, right? So too many questions we have discussed in this session. Just revise all the questions, good number of concepts also we have discussed. Okay, so do revise this session. Bye bye.